Hello, mathematicians. Here we go on lesson 22. The work this week is adding and subtracting fractions using line plots. So that will be super fun. All right, let's get started. So first we just warm up our brains. So you need your whiteboard or something to write on and give these a go. Go ahead and push pause and solve them and then come back and see if we agree. All right, welcome back. So 4 1/4 minus 3 1/4. Let me see if I can get my tools here to work for me. I think that I would solve that I would do the 4 minus 3 and get 1. So I did that part first. And then I have 1/4 minus 1/4, which is 0. So I'm getting 1 for that one. On the second one, 5 minus 2, 3. 1/2 minus 1/2, nothing. Then on the third one, I'm going to do it the same way. 7 minus 3 is 4. Now here we have 3/4 minus 1/4 leaves me with 2/4. Or you could say 4 1/2 or 4.5. Those are all correct. So hopefully we agree for the warm-up. Let's give this a go. So our first read, we're just going to ask ourselves, what is this problem about? Emma's class has a jar of earthworms. Lovely. The class measures the length of each earthworm and records the data in a line plot. What is the difference between the lengths of the shortest and the longest earthworms? So what is this problem about? Worms, and they're measuring them. So this is a line plot here. All of these are inches, and each little X there represents a worm. So it's about worms, measuring worms. Second question, what are we trying to find out? Emma's class has a jar of earthworms. The class measures the length of each earthworm and records the data in a line plot. What is the difference between the lengths of the shortest and the longest earthworms? So what are we trying to find out? Starts right here with the what. We want to know the difference between the longest worm and the shortest worm. There's lots of questions you could ask by looking at this chart, but they want us to find out what's the difference between the longest worm and the shortest worm. Okay. Third read, what information is important? Emma's class has a jar of earthworms. The class measures the length of each earthworm and records the data in a line plot. What is the difference between the lengths of the shortest and the longest earthworms? So right here, they mentioned shortest and longest. So when we come down here to length is really obviously important. Each X represents a worm. So we've got the longest there, 6 3/4. That's a pretty good size worm. 4 3/4 might be like, not quite a whole X, no, not a whole expo marker, maybe just to there. Okay, so that's the important information. All right, now give it a go. You can use your fraction pieces or whatever fraction parts that you have, number lines, numbers, give it a go. So push pause, then come back and see if we agree on the answer. Welcome back. I hope you push pause. So to solve the difference for this one, I think I will do it, let's see, it's going to be 6 3/4 because that's the longest, minus 4 3/4. Since they're both in quarters, I'm thinking the easiest for me is just to go take the wholes, 6 minus 4, and we get 2 inches. And then 3/4 minus 3/4 is nothing, so it would be 2 inches. Got to make sure I put inches there. Check and see if you did. So I'm just doing it number style, but there's many ways to solve it. Hopefully we agree. On this one, we ask ourselves if we were with each other, how did your partner do it? Think to yourself, how else would you solve it? Always pushing our brains on lots of ways to solve it. You could do a number line, you could do a picture. You can make it all into fourths. All right. Make connections and explain your thinking. Explain how to find the difference between the lengths of the shortest and the longest earthworm. So I guess to explain it, you take longest minus shortest. So that's what you're doing. And I did it, my strategy, I guess, that I used was whole number first and then the fractions. Maybe your strategy was different. Okay, so I did wholes minus wholes and then parts minus parts. A line plot is a data display that uses marks above a number line to show the number of times a data value occurs. Each data value is represented with an X. So it's really important that you understand that. People get confused on that often. What the X represents is important, depending on what story this one's trying to, each line plot is trying to tell. So, how many measurements are recorded on the line plot? Explain how you know. Okay, how many measurements are recorded? Well, it goes from 4 to 7, but we didn't record anything on 4 and 7. So we got something on this one. 2, 3, 4, 5, 6, 7, 8. Looks like 8 of them have an X above it. So I'm going to put 8 have an X. What do the 2 X's above 6 1/4 represent? I'm going to erase some of my mess so we can read that. I'm sure you can see your paper is much better than my mess. So when you look at 6 1/4, each X represents what? Know-it-alls? You're right, an earthworm. So I'll get my marker again. So the 2 X's would be 2 earthworms. Okay, remember I'm writing with my finger, so thank you for allowing my messiness. Number C, what length are the greatest number of earthworms? This is one people often mess up. So what length, so we're going to give the length is all down here. It's going to be one of those numbers. So which of the lengths has the greatest number of earthworms? Well, that's got to be this one, because this one right here, because it's got the most. So what length is that one? 5 1/2 inches is the length. So the most earthworms are 5 1/2 inches. 1, 2, 3, 4, 5. Explain would be there are 5 X's. Okay, I can't fit that in very well, but hopefully you can. 5 X's. Another earthworm has a length of 5 3/4. Show this on the line plot. So it wants you to add a piece of data. I'm using my eraser. So if we had another earthworm, I'm going to just use orange. Another earthworm is 5 3/4. So if I'm 5 3/4, put an X, using the right key there, X. You always try to make your X's the same height. So when you make your X in there, make it the same height so you can easily tell which one has more. All right. Next one. Reflect. If the number line is divided into fourths, why are numbers such as 4 1/2 and 5 used to label the number line in the line plot? If the number line is divided into fourths. So if we go back real quick, it's all into fourths. So why do they put like a 5 and a 4 there? You can push pause, write your thinking down. Welcome back. Ooh, I would like a bigger text. Oh well. Maybe I can make that bigger right here. Yeah, let's use 22. Okay, if the number line is divided into fours, why are numbers such as 4 and a half, 4 and 1/2, and 5? So I would put, not type here, that would be weird. I would put 5 is, whoops, not plus, equal to, 5 would be the same as 20 fourths, or 4 and 4 fourths in this case, since it's doing each one. Very good fraction. I'm not liking that, so I'm going to switch to pen so you can see it. 5 equals 4 and 4 fourths. Okay, because 4 fourths makes 1. It's much easier to understand a 5. And then 4 and 1/2 would be the same as 4 and 2 fourths. But these numbers right here, these two are more familiar. So that's, I mean, we don't usually say, I would like 1 and 2 fourths of a sandwich. We would say, I want 1 and 1/2 of a sandwich. It's just more friendly numbers. Okay. All right. On page 465, you need to write line plot in the middle. This vocabulary page is about line plots, which is what we're going to be doing all week. Fractions and line plots. So a line plot, let's see, and let me start with a non-example. Something that you would not be able to line plot might be like colors, number of colors of M&Ms or Skittles or something like that. I suppose you can line plot it, but you probably wouldn't. Or like, what's the favorite sports of the know-it-alls? You wouldn't really line plot that. Okay, line plots are often when you want to keep track of how many, it's often a measurement, lengths, size, hat sizes, shoe sizes. Often it's a measurement and then how many you have of that item. So it's often done with that. Illustrations, draw yourself a line plot and give it a label. Books read by the know-it-alls, something like that. That can be your illustration, just to actually draw one. Examples can be other things you might do. I probably would do books read by the know-it-alls for the examples here, because I could make a line plot that would show like how many students have read 30 books, and I could have each X could represent a student. I actually might use that for a line plot. Okay, so think about an example that you might use for line plots. All right, and then you get to do on your own page 466. All right, see you next time, mathematician. Have a great day. Bye. And